Okay, so G is a group. A mapping will send G to the inverse of G because every element in a group G has an inverse. Okay, we'll send G to G inverse. So it is a group homomorphism. So let's say I have element G. I let G1 belong to G. So what is the image of G1? G1 inverse, right? Because by definition, inverse image of G1, G1 inverse. Then in element G2 again in G. Image of G2, G2 inverse. Now, what can I do with G1 and G2? Okay, multiply them. So, let's try them. G1, G2, multiply them. What does it go to? Of course, it go to image of G1, G2 should be, by definition, whatever number you have, whatever element you have, should be inverse of G1, G2. So, what you can ask now, is this equal to image of G1 times image of G2? If this is true, then you have a group homomorphism. If this is not true, then it's not true. It's not a group homomorphism. So, is it true or not? Okay, so what does the image of G1? Image of G1 means G1 inverse. Image of G2 means G2 inverse. So the question is G1, G2 inverse, is it equal to G1 inverse, G2 inverse? Okay, now group theory is a very, very powerful result here because this is usually not true. Where is the inverse of G1, G2? Group theory will tell you inverse of G1, G2 is what? G1, G2 inverse times G1, G2, right? Must give you what? E. G1, G2 inverse times G1, G2 must give you E. So what should it be? Huh? You see that what should it be? Very easy to understand. What is this thing? Just try and error, you know the answer is this one. Do you agree? Check. Look at this one. G2 inverse, G1 inverse. Multiply by G1, G2. What do you get? Do you get E or not? Multiply, you see? G1 inverse of G1. Multiply, what do you get? Get E. Right? That E, right? Anything now E is no change. So G1 inverse of G1 is E. Right? Then G2 inverse of E times G1, G2, you get E again, right? So you know that this is true. So in general, this is not true because left hand side is actually G2 inverse, G1 inverse. So you ask yourself, is it true? Generally, this is not true, right? It's not the same. In general, the group multiplication cannot anyhow switch position unless it is commutative or abelian. Okay? In general, you cannot switch position. Although some of the operation can switch like normal addition, you can do A plus B and B plus A the same, A times B and B times A the same, but this is binary operation, right? This binary operation, I don't know what kind of operation is that. Okay, what kind of group is G there? We don't know. We just think there's an operation there. So this is not a group operation. This is not a group homomorphism, right? The left hand side, right hand side, not the same. Right? Left side, right side, not the same in this case. In general, sometimes it's the same. It depends on what is the group operation you have, what kind of group you have. But in general, it doesn't go. So this is not a group homomorphism now. Right? So this mapping here is not. In general, right? In special cases, maybe you work, but this case, in general, it doesn't work here.